LangGraph employs a streaming execution model to provide real-time updates during graph traversal, enabling dynamic observation of node-level processing and state evolution. This mechanism facilitates granular visibility into the computational pipeline, particularly useful for debugging and monitoring complex workflows. The upcoming code snippet will demonstrate how to iterate over the graph's streaming output, inspecting each node's updates and message transformations as they occur. This pattern establishes a foundation for understanding how LangGraph manages state propagation and node interactions in a reactive manner.
For chunk and graph.stream, messages, role, user, content. What does Lillian Wang say about types of reward hacking? For node, update in chunk items. Print update from node. Update messages -1, pretty print. Print \n/n.
This code demonstrates streaming execution of a LangGraph workflow, providing real-time updates as the graph processes a user query. The pattern uses a generator to yield intermediate states from each node in the graph, allowing observation of the decision-making process in an agentic RAG system. The graph.stream method returns an iterable that yields chunks of state updates as they occur. Each chunk contains node names and their corresponding state updates, which in this case include messages with tool calls and responses. The code iterates through these chunks, printing the node name and the most recent message content using pretty print. This streaming approach is particularly useful for debugging and monitoring complex workflows, as it exposes the internal decision points and data flow between nodes. The trade-off is increased verbosity in the output, which may not be suitable for production environments where only final results are needed. The pattern assumes the graph has been properly compiled with nodes that update the shared state, specifically the messages key in this implementation. Let's break it down.
For chunk and graph.stream,
iterates over chunks of data produced by the graph.stream method. The loop processes each chunk as it becomes available from the streaming operation, allowing for incremental handling of the graph's output rather than waiting for the complete result.
Content. What does Lillian Wang say about types of reward hacking?
Creates a dictionary entry with key, content, and value. What does Lillian Wang say about types of reward hacking? As part of a larger data structure.
For node, update in chunk items. Print update from node. Update messages -1, pretty print.
Iterates through each key value pair in the chunk dictionary, where node represents the key and update represents the associated value. For each iteration, it prints the node identifier and then calls pretty print on the last message in the messages list within the update dictionary. This displays formatted output for the most recent message from each node in the chunk. LangGraph streaming execution model provides real-time visibility into node-level processing by yielding intermediate state updates as the graph traverses. The pattern demonstrated here uses graph.stream to iterate over chunks of state updates, with each chunk containing node identifiers and their corresponding message transformations. By printing the node name and the most recent message via pretty print, we observe the dynamic flow of data between nodes in an agentic RAG system. The key insight is how this streaming approach exposes the internal decision points and state evolution, making it invaluable for debugging complex workflows. The trade-off is the increased verbosity of output, which may not be ideal for production environments where only final results are needed. This pattern assumes the graph is compiled with nodes that properly update the shared state, particularly the messages key, enabling this granular observation of the computational pipeline.
The stream carries Bob's name through, threaded like a river. But Userid stands parched on the opposite bank.